Hi guys, welcome to Work, Energy and Power, Grade 12. Today we're going to be taking a look at a couple of exercises. Without further ado, let's get to it. The first problem is a work problem, and it states an elevator with a mass of 1000 kilograms is being pulled up by a constant tensional force of 9.8 kilonewtons for a vertical displacement of 12 meters. Determine the work done by both gravity and tension. Let's take a look at the solutions. First, we're going to calculate the work done by tension. And you know the formula of work. It is work is equals to force multiplied by displacement multiplied by cos of theta. Substituting in everything I know given by the problem statement, I will have work done by tension is equals to 9,800 newtons. Remember, the work that I was given in the problem statement is in kilonewtons, and you have to convert it to newtons. That is, multiply the 9.8 by 1000 and it will give you 9,800 kilonewtons. The displacement I was given as 12 meters. That's fine. And the angle, because it's vertically upwards, it should be 0. And that should give me an answer of work done by tension is equal to 117,600 joules. Now let's move on to work done by gravity. Again, the work formula is the same. I've just substituted in the gravity, as you can see, and substituting in all the values that I know. I know that the mass is 1000, and hence the weight will be 1000 multiplied by 9.8. The displacement is still the same. Now the cos angle has changed. It's cos of 180 degrees because gravity is not in the same direction as the tension or as the motion of the mass, and hence its work will be negative work because it opposes the motion of the object, and that will give you the work done by gravity of equal to negative 117,600 joules. Pretty simple. Let's move on to the next example, which is a work energy theorem example. And the problem states a pendulum with a mass of 25 kilograms is attached to the roof. It is pushed up to point B, which is a height of 1.5 meters above the equilibrium position. Calculate the speed of the pendulum when it reaches point A, equilibrium point. Ignore the effects of friction on the pendulum. Let's see the solutions. First, I know that the mechanical energy before is equal to mechanical energy after, because the only forces acting on this object are conservative forces. There are no non-conservative forces, as the problem statement has told me to ignore the effects of friction, and hence the only forces acting here is the gravitational force, and hence mechanical energy before should equal mechanical energy after. Substituting in the formulas, I get the following: initial kinetic energy plus initial potential energy is equal to final kinetic energy plus final potential energy. And I know that those formulas are represented by the following formulas. And now I'm gonna try and make velocity the subject of the formula. So, and hence I have moved to 1/2 mvf squared to the left hand side and everything else to the right hand side. And now I'm gonna substitute in all the values that I know so far, and punching that in the calculator, I will get 12.5 vf squared is equals to 367.5, and making v the subject of the formula, I will get a final velocity of square root of 367.5 divided by 12.5, and final velocity should equal 5.42 meters per second. Let's move on to the next example, which is again a work energy theorem example. It states a forklift lifts a box of 250 kilograms mass vertically upwards through 3 floors with a constant velocity. Each floor is 5 meters high. Calculate how much work the forklift does on the box. Neglect the effects of non-conservative forces. Let's take a look at the solutions. First, I'm gonna punch down the work formula as you know it, and then I'm gonna substitute in everything I know. 250 multiplied by 9.8, that's my weight, and because each floor is 5 meters and there are 3 floors, it will be 5 times 3, and the displacement is in the direction of the motion, and hence the cos theta will be 0 degrees because it's in the same direction. That will give me a work done by the forklift of 2,450 multiplied by 15 multiplied by 1. And that will give me work done by forklift of 36,750 joules. Now, let's take a look at this example. It's an energy conservation example. A mass of 65 kilograms is sliding up an inclined plane with an initial velocity of 12 meters per second. The initial height of the slope is 3.5 meters. Assuming that the coefficient of friction between the mass and the plane is 0.2, find the final speed of the mass at the top. Refer to the figure below for further information. We can see that the angle is 30 degrees and the height of the slope is 3.5 meters and the mass is 65 kilograms. Solutions. First step, I know that frictional force is given by mu multiplied by normal force, and I know that normal force is mg cos of theta, and substituting in everything I know, I get a normal force of 0.2 multiplied by 65 multiplied by 9.8 multiplied by cos of 30, and hence the frictional force will be 110.33 newtons. Next, let's find the displacement, because so far I'm only given the height of the slope, not the displacement that the object travels in. And now I'm going to find the displacement. I know that sine theta is equal to opposite over hypotenuse. The hypotenuse is the displacement that I want, and hence I made the displacement the subject of the formula, which gave me displacement is equal to height divided by sine of theta, and substituting in all the values, I get the height of 3.5 divided by sine 30, which is equal to 7 meters. Now, I write down the non-conservative work formula, and substituting in that formula, I get final kinetic energy minus initial kinetic energy plus final potential energy minus initial potential energy. And now I'm gonna substitute in those formulas, and I will get the following formula, as you can see. And now I'm gonna substitute in my values. As you can see, the 110.33 multiplied by 7 multiplied by cos of 180, because friction opposes the motion, and hence its angle should be 180 degrees, is equal to 1 over 2 65 vf squared minus 1 over 2 65 multiplied by 12 squared, because I was given the initial velocity, plus 65 multiplied by 9.8 multiplied by 3.5, that is the final potential energy, minus 0, because the initial potential energy was 0, because the height was 0 at the bottom of the slope, and hence if h is 0, the whole potential energy becomes 0. Now, simplifying that formula a bit, I get negative 772.31 is equal to 32.5 vf squared minus 4,680 plus 2,229.5, and making vf subject of the formula, I get 32.5 vf squared is equal to 1,678.19, and hence making vf subject of the formula, I get vf is equal to square root of 1,678.19 divided by 32.5, which gives me a final velocity of 7.19 meters per second. And that is how you treat that particular question. Pretty simple, bit long, but overall simple if you know the basics. Moving on to a power problem, and the problem statement states a bodybuilder lifts a 300 kilograms mass 0.25 meters vertically upwards in 5 seconds. What power is delivered by the bodybuilder's biceps? Let's take a look at the solutions. You know the work formula. Work done by non-conservative force is equal to change in kinetic energy plus change in potential energy, as I've shown you. And substituting in, I know that work done by kinetic energy will be 0 because initial velocity was 0, the weight was resting, and the final velocity was also 0 because it stopped at 0.25 meters, and hence the kinetic energy in this equation will be 0, leaving me with in the formula with work done by non-conservative force equals to work done by potential, change in potential energy rather, and hence substituting in that formula, and now substituting in the values, I get work done by non-conservative force is equal to 300 multiplied by 9.8 multiplied by the change in distance, which is 0.25, and hence work done by non-conservative force is equal to 735 joules. This is the work done by the biceps of the bodybuilder. And now I'm looking for what? For the power that it delivers. And we know the formula of power is equals to what? Work done over time, and substituting in the work done that I've calculated above is 735, and the time is 5 seconds as I was given by the problem statement. I get the power of 147 watts. And that's the end of that question, and hence the end of this lesson. Thank you for watching. To support the channel and help more students access free lessons, please like the video and subscribe if you're new to the channel. For additional learning materials and updates, visit our website using the link in the description below. Keep studying hard, and I'll see you in the next one. Cheers.